Hello, Abhishek.
Hello, madam. Good afternoon.
Good afternoon. So today's second session will be on hands-on, right? Continuation of yesterday's session.
Yeah, it would continue the previous session.
Yeah. Okay, so it's 2 o'clock. Shall we start or shall we wait for another 5 minutes for people to log in?
It would be better that we will wait for some more time because I see many new faces. I mean, new people joined for the session too. So we'll wait for the yesterday's you know participants also.
Attendance.
Yeah.
Okay. Dhruti will wait for around 5 minutes and then I think when Abhishek is okay, we'll start the session. Dhruti? Dhruti?
Yes, ma'am.
During the session, did you capture some photos yesterday? Photographs?
No, I will.
Okay, I think today we can capture some photographs. Shall we start, Abhishek? It's already 2:05.
Come back at 7.
Okay, fine. Once he is ready, he tells to start, we'll start. Your voice is breaking, Priti. Yeah. Apeksha is from which place? Apeksha?
Bangalore,
Bangalore. Which college?
Sai Vidya.
Vidya. Yesterday you attended the session.
Yes,
Was it useful?
yes, was.
Okay.
Hello, good afternoon to all the 10 participants. So before we start, can I just check with you if you have installed the Arduino IDE, which we discussed in the previous session? Apeksha, Mithan, and Shreya, have you got your Arduino IDEs installed on your computers? Dhruti, actually, your voice is a bit low, and sometimes it freaks out.
Is it fine right now? Abhishek?
Yeah, we'll try to amplify it by ourselves.
1 minute. start the session?
Abhishek, shall we start?
Yeah, ma'am, we are good to go.
Okay, so Dhruti, we'll start the session.
A very good afternoon, one and all present here. I heartily welcome to Gurukul, the second session hands-on workshop on robotics. Today embarks the second day of the workshop. Due to the pandemic, this workshop is conducted online, so kindly bear with us for any technical issues. We will resolve them as soon as possible. I request all the participants to mute themselves during the session and put their queries in the chat box. It will be addressed throughout the session. This work is being conducted in association with Pylon. Pylon, newly established educational platform that focuses on providing quality content to students and assisting them on their academic journey. It was founded in 2020 by a team of enthusiasts, recently graduated engineers who have a vision of providing quality content and educational courses to enthusiastic experiences and knowledge levels. Pilot's motto is to help students learn without limits. Team Pylon believes that students should be able to access a vast amount of being restricted by course curriculum or rigid academic requirements. Pylon provides a wide range of carefully curated courses targeted towards learning of different knowledge levels at or negligible costs. Each course is thoroughly researched, carefully put together by Team Pylon, and approved by a subject matter expert. The courses on Pylon span multiple different categories such as data science, programming, engineering design, blockchain, digital marketing, content marketing, embedded systems, and even on personal and financial development for young adults. Before we start the workshop, I would also like to introduce the speaker for this event, Abhishek Srinivas. He currently works for L&T and is associated with. He's also the former founder chair of IEEE University, the core team member of IEEE India team, and a member of SET IEEE India Council from IEEE Bangalore section. He has taught embedded systems related project-based courses to more than 1,000 students from both schools and colleges. We're glad to have you here with us, Abhishek. Over to you for the rest of the workshop.
Thank you, Shruti. Thank you for the nice and warm introduction, just like the way you did yesterday. Okay, so today we shall go ahead with the hands-on part. Yesterday we had a part of theory as well as some amount of hardware connections and hands-on. So today we'll focus and then we'll try to touch upon the hardware connections and the uh, and programming part and also the connection part. All right, so moving ahead. Yesterday we saw how to connect hardware on tinkercad. There was an issue with the tinkercad. The issue was there was only PIR sensor available. The actual infrared sensor module was not available. So today I found a better solution for that. So today we shall make use of circuit.io. Okay, circuit.io is also a website. I mean, that's a web application wherein we can simulate the hardware parts. All right. Okay. So I'll be sharing my screen with you. You just see if it's visible to you guys. All right. Okay. Do you folks see my screen? A quick thumbs up because we have got much to discuss today than what we got yesterday. All right. So uh, we yesterday we saw two types of infrared sensors. I mean, uh, the one sensor with four terminals and the other one with three terminals. So if you can look at here, look at this particular infrared sensor, it has got only three. If you can zoom it, yeah, just give me a second. I'll try to zoom it. Okay, here you can see it has got output pin. That is, if there are only three pins, and it would be uh, digital input in most of the cases, sorry, digital output in most of the cases. So we have got one output, and then we have got the ground, and then we have got VCC. So as we discussed yesterday, VCC and ground are for the powering part, and then this output terminal is the signal part, right? So in the same way, if we are targeting to work on the obstacle detection bot, we need two infrared sensors. I mean, one infrared sensor, would do, but it's a better practice to use two infrared sensors in front of the bot. So so that we divide the space in front of the bot into left and right halves. It it will check for the obstacle in the left and in the right. So if the left is detecting any obstacle, it means that it cannot go to the left, so that it has to turn to its right. So if there's obstacle in the left, we should stop the right wheel, and then we should turn on the left wheel, so that the uh, the bot takes a 90-degree, or a corresponding turn to its right. In the same way, if there's an obstacle to in the right side of the bot, it means that it cannot go to to its right, or it cannot march forward. It should take a left. So in that case, we are going to stop the left motor. I mean, the left wheel shall be made to stop, and the right wheel shall be made to turn on, I mean, made to move ahead, so that the bot shall take a right curve, a curve to its right. So this is the logic behind obstacle detection bot. And in case uh, both the sensors detect an obstacle, it means that there's a big wall kind of thing, or something huge ahead of it, so it cannot go forward, right? So in that case, the bot has to stop where it is, or the other condition is it has to go back. All right. So this is the logic. So we have got three cases as of now. If there's an obstacle to its right, obstacle at its left, and if what if both the sensors detect the uh, obstacle, right? So we shall write the logic for these three conditions. Okay, here we need two infrared sensors. Not look at the terminals, the connection terminals, because you can vary it, you know, uh, like in whichever manner you want. Okay, so now I'll be selecting one more infrared module. Okay, the best part about the circuit.io portal is, it will make the connections automatically by itself. Okay, if you can look at here, yesterday we were speaking about the common ground. Just look at this. Just a minute. Yeah. So there is a ground here, and at the bottom, the ground, starts from the power sector of the microcontroller, and then it comes here, till this point in the breadboard, and from there we have made the common ground for this particular, IR sensor 1 and IR sensor 2. So this is nothing but common ground. And here, as you can see here, in the same way, we have got a common voltage, I mean common supply voltage. So you can know these two, VCC and VCC joins here, and then in turn it starts from this point, and then it goes all the way till 5 volts. Get it? So this is nothing but common ground and common supply. So we can use a common supply for both the sensors, because these will be running somewhere around 3.3 volts, and then here we will be giving 5 volts. Okay, there shall not be much of a voltage drop, so they might work properly. So assuming that that condition, we shall be making the connections. Sometimes what happens is, sometimes if you connect the third infrared sensor or the fourth infrared sensor, okay, the sensor might not get proper voltage. So in that case, you might get some garbage values, or or some abrupt values from the sensor, from the sensor. In that case, we should use a dedicated supply for the terminal, for the sensors and the different actuators. So for now, just keeping in mind that we will be having in the mind that ideally the voltage shall be enough for both the sensors. So with that in the mind, we shall move forward. All right. So both the sensors are connected. And then what do we need? We need a pair of motors. Okay. So here the pair of motors, um, is a combination of actually it's a combo. It has got two motors along with a L298D. Yeah, it's L298N. Okay, it's not L298D, but it's L298N, but of the same family. So it'll do the same purpose. Okay, so this is the motor driver module which we were speaking about in the yesterday's class. So what is the reason? Can somebody tell me? I mean, out of the four people who have been active in yesterday's and today's session, can someone tell why we are using L298 motor driver module? Come on, Apeksha, Dhruti, and Shreya, Vaishak, you are there yesterday also, right? And someone asked me a question about this. Why do we use L298D motor driver? Okay, no problem. I'll just discuss it again. So we cannot power these motors, direct. Just a minute. Yeah, so we cannot power these motors directly from from the uh, from the power sector of the Arduino board. If you can hover over this motor, you can see it. It's a motor with 90 RPM, 90 rotations per minute, and then the operating voltage is 6 volts to 12 volts. Okay, this is motor one. This is motor 2. And then what is the input for this? The input for this is 5 volts. I mean, what is the output from the terminals of Arduino? It's 5 volts. So how can we power up two motors with a minimum of 6 volts from a 5 volt supply? Say if if both the motors are running at the same time, like if there's no obstacle ahead of the bot, and then the Arduino says we can move freely, we can go forward. The In that case, both the motors will be running, at 90 RPM. Okay, at that moment, this 5 volts shall be divided between this motor 1 and motor 2. So hardly it'll get around 2 to 2.5 volts. So with that 2.5 volts, it can't even start moving. And we cannot think of running, but we cannot even think of starting the movement. Of course, if the motors gear, if this motors gears are not to that extent, we cannot. Right. So there are conditions where it depends on the motors which you use. If we use the motors which work on a lesser operating voltage, in that situation we can make use of the voltage and current which is being supplied from the terminals of the Arduino IDE. All right. So for that reason we shall be making use of the motor driver. In this case, we shall be using an external power supply. uh, okay, where is he using? Okay, you can see here, this ground and this particular voltage you see here. So in here he has not used up external power supply, but it is suggested that we use external power supply, based on the requirements of these two motors or whatever actuators we have got in the circuit. Okay, so this particular motor driver, it accepts the command from the motor from the Arduino IDE, so from the Arduino microcontroller board, and then it will turn up the motors, right? So this is the circuit for that. Now let's look at the code part of this. So any doubts still here? All right. So this is the IDE you know that we are using for today's programming. So as we discussed yesterday, we need to first declare the variables. We shall declare the variables as global variables. So for this particular coding, it is suggested that we have the fundamentals of C programming. We know what is an integer, what is a character, and then what are different types of data types. Then what is global declaration, what is local declaration, difference between printf and scanf. And on top of that, you should be aware of the yesterday's terms, like serial print, serial, yeah, it's digital read and digital write, analog read and analog write, and what's baud rate, all those things. Okay, so with yesterday's knowledge in the mind, we shall move forward. I shall be declare. Okay, do you guys see the circuit connection? Is it visible to you? Hello, am I audible to you? All right. Yes. So this pin number, the output from this particular sensor IR1 is connected to pin number. If you can zoom it, it's connected to pin number 9, right? And the output from the first IR sensor, that is, this brown line, it is connected. It is running all the way through this, and then it's connected to pin number 8. So we shall be making use of pin number 8, 8 and 9. And before going to the coding. Yes. So somebody in yesterday's session, is it okay now, Dhruti? Is my connection stable? Does it look stable to you?
Yes, Abhishek.
Okay, thanks. Okay. In the yesterday's session, someone asked me about, they see a compilation error, and the online, the cloud audio ID says that the particular board is not selected. So that problem shall be dealt with here. Okay. Here, you should go to tools, and then you should, select the board, which particular board that you are using for this particular project. And then, based on that particular board, the IDE shall set, shall configure the programming conditions and also the terminal numbers. Okay. So in this case, let's go with Arduino Uno. So yesterday we were discussing about the Arduino family of microcontrollers. You can see here, we got Arduino. Okay, we got Arduino Micro, Leonardo, Mega, Nano, or Mega 2560, and Arduino N. In my 4 to 5 years of of work experience with this microcontrollers, I have never worked with Arduino N. Apart from that, most of them I have used. So I don't know, if it's available only in China or if it's even available outside it. All right. So this is where we are gonna select the board which we are working currently. Okay. And if there are any libraries, there are off-the-shelf available libraries, from different programmers. It's available in the community. It's available even in the Element 14 community and also in the Arduino community. So you can include those libraries here. Say for example, if you are working with with a keyboard, or with a Ethernet module, or say you're working with a E square PROM. I mean that's EPROM or Wi-Fi. In that case, there is no need for for you to start the code right from scratch. You can make use of the libraries, and then you can call those functions, and then you can run your program. This is how it's gonna work. Okay, so that compilation error is due to this problem. So this problem is now solved. Okay, let me just connect these IR sensors to the board. I mean, let me define this first. So it's connected to pin number 8 and pin number 9. And these motors say they are connected to pin number 4 and 5. I'm not looking at the circuit connection right now, because I need to stop sharing and then go back to the website and start sharing. All right. So what next? Can somebody tell me from the yesterday's session? Because we got to define the mode of operation, in which mode these particular sensors or actuators are connected to our microcontroller, right? So we need to define the pin mode. Okay, pin mode. My IR1, I can use IR1, or either pin. I can directly call the pin number. Okay, I can call the pin number by number 8, and I can say it as an input. And in the same way, I got pin number 9 as input. Then what next? 4 is output. And 5 is also output, right? Okay. So next, what do we have? We need to store the values. We can directly work on the values, but it's better, if you're if you're a beginner, or if you're a newbie to the to the programming or the embedded system community. It's better that you use a third variable for storage purpose. Okay, let me use C. Okay, IR1A and IR2B. Okay, so these IR1A and IR2B correspond to the output values from the IR1 and IR2 respectively. All right. So okay, what happens if you declare it again? Int it's declared IA1. Actually, the variable IR1A is declared. It's as an integer. Now, what happens if we declare it again here? There are chances that there can be redefinition errors. Okay, so to avoid that, we shall define all the variables in there as global variables, and then we shall make use of them within the code, anywhere within the code. Okay, we got IR1A equals, it still read IR1. So whatever value of IR1 is being digital read, and it's being stored in the variable IR1A, right? Getting it? And in the same way, we have got IR2B. The variable IR2B will be storing the value from IR sensor 2, right? Now comes the logic part. Okay, and then you should be very careful about this setup. Okay, definition of the variables, and then declaring the pin modes, and then in the void loop comes our actual logic. You cannot directly jump onto the logic, because you should set your board, and then you should define the terminals. Okay, now we are going to use the if and while, or if else conditions. If IR1 A double equals to high. So, so the most common mistake that I have seen that newbies to the to the C programming domain do is they just make use of a single equal to equals to a symbol. So when you use single equals to symbol, it'll be like assigning. Okay, if you use double equals to, it'll be comparing. Okay, if I use only single IR1 equals to high, that means that I am telling IR1 is has got the value high. If I use double equals to, it means that I'm comparing if the I'm checking if the IR1 is high, right? So this is the difference between a single equals to and double equals to. Okay, so in that case, if IR1, say if the left sensor is is sensing high, that means if it has got an obstacle, okay, we should define this. If there's no obstacle, it should keep it should keep running. If there's an obstacle, it should stop running. All right. So if there's any obstacle, if there's any obstacle in the left side, I should make the motor one, that is M1. M1 means the motor to the left. IR1 is the left sensor. M1 is the left motor. IR2 is the right sensor, and and M2 is the right motor. Okay, keep it in mind. So I should stop the left motor, and I should start the right motor, so that it'll okay, if it is to the left, we should stop the right, and then we should okay, I should make it the other way around, and M2 should be low. Okay, and then to what time? I mean, to what extent? Wait, for 2 seconds. It'll be 2000 milliseconds. So whatever delay is being given here, it is in terms of milliseconds. So I shall give it as 2000. Okay. Next, what if the right sensor is sensing an obstacle? It's the other way around. M1 should go low and should go high. Okay. Here we need to use an else if kind of condition. And in the same way, what if both the sensors are detecting an obstacle? Okay, so I'm using a double ampersand. That means both the conditions should be satisfied. I'm not using an or condition here. I'm using an and. So if both the sensor IR1 and IR2 are sensing an obstacle, in that case, both the motors shall go low. Now, what does it mean by shall go low? It'll give a logic 0 to the terminal. It'll give a logic 0 to the respective terminal, so that the motor shall go low or it shall stop running. So this is the condition. And we have other condition, which is the default condition. So that condition would be if both IR sensor 1 is low and both IR sensor 2 is low, what shall we do? We should ask both the motors to keep running. Okay, so it'll make the operation for 2 seconds, and then it'll go back to the loop, and then it'll say, it'll start checking if which if the right sensor is high or if the left sensor is high, and the same process repeats in an infinite loop. Okay, so this is about the program for the obstacle avoiding bot. Okay, so let me check if there's any compilation error. So we are going to compile by clicking on this particular check button. So it means that verify. I shall not save this. There's no need for me to save here. Okay, expected token. Yeah, I did not look at this particular closing bracket. So I introduced again one more here. Okay, done compiling. So our compiling is done. Okay, now if we dump the same program, okay, how do we dump the program? We shall connect the board to any of the USB portals on a computer, and then we shall click on port. Okay, the port shall be automatically taken by the computer itself. We shall click on the port. All right. If we dump this program by clicking on this upload, when you click on upload, it will compile the program again. It will check for errors, and then it'll dump the program. Here, it says serial port not selected because I do not have the board in my hand. I don't have the board connected to the computer. So that is the reason it says port not selected. So come back again when you connect the board. All right. Okay. Then again, how do we see the values, and then how do we see what's happening within the board? How do we see the values that are being sent to the actuators, or the values that are being received from the sensors? So for that case, as we discussed yesterday, we are going to initiate the serial monitoring condition. So we are going to begin the serial communication mode with a baud rate of 9600, which we use most commonly, but it's not a hard and first rule that you should use only 9600. Based on the requirement, you can modify or alter it. Okay. So here I should know what is the value that's being read from the sensor, from the IR sensor. The actually the value from the IR sensor is being read, and it is stored in, and it's going to be stored in IR1. So it is enough if I know what is the value being stored in IR1. So for that reason, I'll just print it as serial dot print IR1A. Okay. Here we can make use of print ln also. It goes into the new line, or else it'll be one after the other in the same line. Okay, so I should know what is the value of IR sensor 2. So for that reason, I'll print the value of IR2B. Okay, with this, the coding part is done, and then we'll just go to the particular port, select the port, and then it's not necessary to check the port every time. If you connect the port, it will be taken automatically. All right. If you get an error, or error like serial port not selected, only in that case we need to go back to tools and check if the board check if the board is corrected, is corrupted, or if the cable is corrected, or if both the board and cable are correct. Check if the exact correct port is selected or not. Okay, sometimes there shall be port issues when you are connecting multiple boards to your computer. Now we have initiated the serial monitoring condition, and like, where do we see what is the value that's being received or that's being sent? What is the value that's being serial printed? Okay, we shall click on this. This is serial monitor. If you click on serial monitor, you'll see the value of this particular sensors. Okay, here it says board at null is not available. This condition arrives because the board is not being selected. So that is the reason we are not able to see the output. You can just get your hardware at your hand, and then you can connect them properly, and then you can see the result. So this is about the obstacle detection bot. Okay, all right. So I hope you got the obstacle detection bot, stage by stage. Yes or no?
Sir, hello.
Yeah, thank you, Mithun.
Sir, I have one doubt
Okay,
regarding
yeah.
digital write. Sir, the motor one consider it maximum speed when we give it high. Digital write high means motor will rotate in higher speed. How to control the motor speed?
Yeah. So here, high and low doesn't mean the speed. Here, high and low means either the condition. It means either 5 volts or zero. If you give M2 as low, the board shall be sending it 0 volts. I mean 0 volts, nothing, nothing but it shall not be sending any voltage, to that terminal. Low means zero, high means one, or low is equal to zero, equals to 0 volts, and high equals to 5 volts equals to one condition, it's digital 1 and digital 0. So it doesn't mean that motor will be going in higher speed or lower speed. This is myth number one, which has to be busted. Okay. And point number two, how do we control the speed of the motor? Okay. We cannot control the speed of the motor here, with this particular program. In that case, if we want to control the speed of the motor, we can introduce a potentiometer between the L298 motor driver and the motor. In that case, you can make a voltage drop in the potentiometer, and then you can regulate the voltage, as per your need. And in some situations, there's a voltage regulator module. If you have a voltage regulator module, you can connect that voltage regulator module to the Arduino board, and then you can make it as analog, right? Getting it? You can make use of analog, right? And then you can give the value, say
Yes, sir.
0 to 255 or 0 to 512 or 0 to you know 1024.
Yeah.
Got it?
Yes, sir.
Yeah. Thanks. Uh, okay. So let's now discuss about the line follower bot. Okay. So when we look at the an operation of the infrared sensor doesn't sense a black. We know black is an absorber of all radiation, right? So when you radiate when you power up an infrared sensor and then keep it in front of a black surface, it shall not sense anything, because black absorbs all the infrared radiation. So in that case, our infrared sensor would be a failure case. So we shall make use of this particular feature for the line follower bot. Okay, just give me 2 minutes. I'll just quickly open my Word application. All right. So now you can see my Word application screen, right? Okay. So consider this is the strip. So this is the line or the strip in the line follower bot, or in the maze uh, that you are working on. Okay. So what we shall do is we shall make use of the same code and same set of hardware and the same type of connections, but we are going to vary the the angle of the sensors which we are facing. In the previous project, the sensors were facing front. Okay, it was detecting on obstacle. All right. So when there's an obstacle, the radius would the radiations would bounce back, and then from that we the board shall get to know that there's an obstacle. But here in this case, you are going to face your sensors for the edges of this particular track. Say for example, Okay, here I'll be placing my sensor 1, and in the same way sensor 2. No, sensor 2. Okay, I shall be placing my sensors on my board in such a way that those sensors will be facing, it'll be facing the track, it'll be facing downwards. It'll be looking towards the track. Okay, so when the sensor radiates the signal, the infrared ray, it shall be absorbed by this black. Okay, by sensor 1 and sensor 2. So when it's being absorbed, it knows that there's a black strip, there's a black strip, and then it is on track. And then when this when the radiation is not being absorbed, or when we are getting the voltage as high, it means that this the sensor is facing off the track. That means that the body is going off the track. If it goes off the track to the left, I mean, if the left sensor goes high, we shall make the bot to move to the right. If the right sensor is giving a high, we shall make the bot to move towards its left. Get it? So this is the logic between line follower bot and obstacle detection bot. Both operation, connections, everything would be same. Only the orientation of the sensors would be altered. Okay, did you get it? The line follower bot.
Yes, sir.
Okay, because I had no picture to depict that, so I made use of this. So with this, we covered the line follower bot, and also the obstacle detection bot. We made use of the code reusability property, right? Hardware reusability property, or the code reusability property. Okay. Next, we shall yeah. Next, we shall think about the fire detection bot. All right. All right. I hope you can see the circuit.io page back. All right. So we shall modify the same system into a fire detection, or fire extinguisher bot. Okay. So here in this case, we do not need a obstacle sensor, right? So I shall quickly remove this obstacle sensor, and I shall introduce a flame sensor. So this is a flame sensor. Flame sensor is nothing but the fire, fire sensor. So how does it sense the flame? In that flame, we have got infrared. In that, light. We have got some amount of infrared radiations. And then we also got heat radiations. So those heat radiations are nothing but the infrared rays. So this will be sensing. So can somebody quickly tell me, if possible, only if possible, what is the difference between these two? As you can see.
Transmitter and receiver, and here there is only receiver.
Yeah, perfect. Okay, so this is the basic difference between a infrared sensor and a flame sensor, or in terms of a layman, it's like it is a difference between obstacle avoidance bot and the fire extinguisher or the fire sensor bot. Okay, so here we have a transmitter, IR transmitter, and then we have IR receiver. Why? Because we do not have a IR source. But when it comes to the flame sensor or the fire extinguisher bot, we have a infrared source. That is the heat source. So we just need a receiver. So that's the reason now we have got this receiver. So when you go to in different workshops, or when you or in your part of hackathon teams, sometimes you get a trouble that you have IR sensor, and then unfortunately you or your buddy or your friend missed getting a flame sensor. So in that case, we should not worry for that. We should quickly take out the the stripper or the wire cutter, and then we should just take off these transmitters. Okay, so this is just a model of reverse engineering. Okay, so it is not suggested, but it's a quick help for all of us when we are in trouble. This is called as hardware reusability property. When you go to industries, they'll ask you for how many times you can you can reuse the same hardware by using multiplexing or any other either hardware or by software means. Okay, in that way we can make use of in infrared obstacle sensor and convert it into flame sensor. So there's no need for it. I shall remove this. And in the same way, I can introduce two flame sensor. I mean, one more flame sensor here, to the left and to the right, and I can divide it. And in the same way, I can operate the bot. So it's the same thing. Only thing that's being changed is this sensor. All right. So this is just a fire detection bot. If you want a fire extinguisher bot, what do? We just get a pump. We'll just introduce a water source or a carbon dioxide gas whatever it is. We can make use of a water source on a small water tank on top of the bot, and then we can also introduce a pump, and then we can connect that particular pump to any of these terminals, and then we can make the change in the code accordingly. All right. So if there is a fire to the left, the bot should go to the left. Okay, here the condition would be different. The actual logic would be made different. If there's a fire at the left end, it should go to the left end and then put off the fire in the left. If there's a fire to its right, it should go towards its right and then put off the fire at the right. So we shall also change the mode of operation. I mean, yeah, we shall change this logics of motor 1 and motor 2. That's the difference between this. So coming down to the code, yes. Now coming down to the okay, uh, okay. Now coming down to the code, we shall make changes here. If it is sensing high, we shall make this high and this low. If it's sensing low, we shall make this one low and the other one high. That is the only difference. And we can also rename these IR sensors as flame sensors or heat sensors or something like that. And then if you want the live reading of temperature, you can use a temperature sensor. A temperature sensor, basically we can either make use of the temperature sensor IC, that is LM35 IC, which is in the LM family. And then we can also buy the off the shelf available a temperature sensor module. So this LM35 would be working on the common base or common emitter mode, and then we can make use of its amplification principle to get out the temperature values. Okay, and then we shall be getting the analog values from that, and then we shall make use of analog read. Okay, I'll show you a case how do we read analog. Okay, in the same way, if we introduce a temperature sensor here, int okay, we cannot use temp because that might be a keyword here. We shall use temp underscore sensor. I should be connecting it to pin number 6, and I need a variable temperature score value. Okay, so here I shall assign the value. Value equals analog read, because the readings from that particular module or that particular transistor, LM35 is a transistor. Okay, so that particular transistor will be in the form of analog readings. Done. So I need to see the values, whatever value is being obtained should be printed. I shall print it as serial.print println printed as, or in the same line I can make use of done. So this is how we can modify the code and also the hardware. So we are completed the obstacle avoidance bot and the line follower and also the temperature sensor or the fire extinguisher bot. So in case if you are using a water pump, so we shall say water underscore pump, and it shall be given to pin number 8. And here we are using temperature sensor, right? So we have to define that. I forgot to define that. So it is an input. Then we have got a water pump at pin number 8. So that's an output device. Okay. So in all the cases, if we can make use of this temp value as anywhere as we need. Again, if temp value, since we are using analog read principle, we can make use of the analog values. If you use either 0 or 1 for this analog reading, you shall be in a problem, because it would say either there is a temperature high or temperature low. Even if there's a temperature, like even if there's a voltage of 1 volt, it shall be boosted to the 5 volts. If it is 0, it will be 0. If it's anything more than 0, it shall be considered as a voltage value of high. That means 5 volts, and then it will be encrypted as a high condition. So in that case, our program shall be a failure. So we should make use of analog values. If temperature greater than 250, okay, on a scale of 0 to 1024, okay, based on the bit size, then we can make use of digital write, motor 1 high, motor 2 low, and also we can ask the water pump to go high. Water pump, that is, what is this we are given? Water underscore pump, yeah. Water underscore pump comma high. So the pump goes high. That means that the pump shall pump the water. I mean, like the water pump shall throw out the water, from the tank to the point where there is fire. You can also make use of uh, the servo motors. Okay, servo motors. Why servo motors is you can also control the angle of throwing the water at the fire. Okay, for that case, it'll be much complicated, if you're a newbie or a beginner. So for that, you can make use of MPU 6050. So MPU 6050 is nothing but the angle sensor. It's a gyroscopic sensor. From that you can sense the X, Y, and Z axis of the board, or any object on which it is mounted. Okay, so for now, this is enough, I guess. Okay, this is about fire extinguisher or fire detecting bot. Okay, so these are the changes we made in the code and hardware. Next, at the last, we have is the Bluetooth module. I mean, a Bluetooth wirelessly controlled, a Bluetooth enabled bot. So how do we connect that? Yeah. So as discussed, HC 05 is nothing but the Bluetooth module, and HC SR04. Now we call it as HC04. HC04 is a ultrasonic sensor, and then HC SR505 is a PIR sensor. So here we need a Bluetooth module. Okay, and in this Bluetooth module, we shall not use any sensing part because the bot should accept the command from the user, and then it should be made to move. So look at this connection part. Okay, in this Bluetooth modules, all the namings will be done on the other end of the module. So you cannot see which terminal is connected to which point. Okay, so you can see we have one ground line and one voltage line, and the other one would be the serial and serial communication modes. So here, yeah, there's a major difference here. The way they have connected the module and the way that I have discussed, or or we have discussed, they have made use of TA of pin number 10 and 11, and they have enabled pin number 10 and 11 to be the TX and RX ends. Okay, they are not using the default which is readily available TX and RX ends. So if you go through the code, sometimes the code would be made available here. If you go through the code here, they would be, I have not seen yet, but let me check. Okay. So they would enable pin number 9 and pin number 10 as Bluetooth mode, into Bluetooth modes. Yeah. You can look at this point. Okay. They have enabled this, pin TX, pin 11 as TX end and pin number 10 as RX end. So that's the reason they are connecting to pin number, 10 and 11. But, and, you can see here, they are also using a library, be it a Bluetooth HC05 library.h, that's a header file, a library for this. And this is for the motor driver. Of course, there's no need for the for the driver, for this motor driver. But they have made use of it. Let's go back to design. So here, in our case, we can directly connect the TX and RX sends to RX and TX sends in the on the board. So with that, our connection shall be done. Now we should go back to the um, Arduino IDE. All right. Now, we shall modify the same code. Okay. I shall select the lines of code, these lines of code, and I shall open new project. Okay. All right. So here, if you go by the convention that they have mentioned there in their particular portal, you need to define even the transmission and the reception terminals. But here, there is no need for it because we have the readily available pins on the microcontroller board. So we just need to introduce the motors, because if it is a bot, or it can even be called as a RC car or a bot or whatever it is, based on the requirement and the application. Okay, we just need only two motors, M1 and M2, and then these IR variables not needed. Okay, this temperature sensor. Okay, let it be there. Let this bot be a temperature sensor, temperature sensing bot also. Okay, then we don't need any pump because this bot shall be only sensing but not actuating. We shall modify this. In mode. All right. So we should make the Bluetooth connection now, right? So as soon as you power up your Bluetooth module shall be made enabled. You should connect your enable pin, 5 volts to enable pin of your Bluetooth module and VCC and ground. If you connect these three pins, your Bluetooth module will be powered up, and then it will start, showing out its name or its SSID in the Bluetooth range. Okay. Now, how do we configure that Bluetooth module to our board? Okay, it's pretty simple. We just need to connect the TX to the RX and then RX to the TX. So connection wise, it is done. So hardware connection, okay, it's perfect. So how do we tell our microcontroller to accept the serial communication values from that particular Bluetooth module? So for that, we should write a pair of lines of codes, a couple of code, a couple of codes of lines, yeah, whatever it is. So here it should be F serial dot available. Okay, so this is serial dot available function. Okay, this function would check for any serial communication values that are being fed into the board. Okay, so here we shall enter into the loop. What does it mean if serial data available? If there is any data available through the serial communication mode, that is through the TX and RX pins of the board, then get into the loop. If there's any serial data available, then we shall get the data and then we should work on the data. Okay. So now we need a variable to store the data or to read whatever data is being received by the Bluetooth module. For that reason, I shall declare one more variable as value. Okay. So here I shall say within the serial available loop, value equals to serial dot read. Serial dot read. Okay, value is equal to serial dot read. This is enough. Okay. So whatever is being read serially, it will be stored in that particular value. And again, based on this, we shall draw our logic. If value equals to high, if you or if value equals to high, or in some cases you can give the values of 0, 1, 2, 3, 4 or 5, 5 and 6, if it is integer. If you are giving a character, suppose you are connected your Bluetooth module to the Arduino board in the first end, and in the other end you have your Bluetooth HC05 Bluetooth application on your Android phone, and then you shall be sending a value as a letter A, or a letter F. Okay, say for example F, F means forward. So if the value, if the if the stored value of this particular variable value is f, we should check for that is f. Then again, digital write m1 comma high, and both the motors should go high. M2 comma high. Done. Okay. Next, else if the value of of the serial read is something like yes, it means that the bot should stop. So we shall give it as low. And if there's a condition something like if the value received is L, L means acts as the bot to go to its left. In that case, if it's L, uh, okay, M1 should go high or M2 should go low, or the other way around. It's like that. This is how we are going to make use of Bluetooth module for serial communication. So with this, we come to end of the serial communication using Bluetooth module also. So we have covered 4 projects. The first one is the obstacle detection. Next comes the fire extinguisher, and then next comes the line follower, and then at the end we have this fire extinguisher. Okay, so I have showed you how to work on this. Next, we are open to questions. So these questions, which you can ask might not be only related to these 4 projects. We can brainstorm on different projects and then different ideas.
Sir, what if we send small s instead of capital S?
Okay, in that case, you should make those changes here. If it is capital S there, at the transmission and transmission end, it should be a small s, a lowercase s here. It should match. It should also be case sensitive. Okay, and one more thing here, this value here we are using alpha, letters of an alphabet. So we should change this to character, because int, it doesn't come under the integer data type, right? Yeah. If you're sending uppercase A, it should be uppercase A. If it's uppercase, if it is lowercase b, it should be lowercase b. And then so we have enough time. So meanwhile, you can try it on your PCs and then check if there are any errors.
Sir, can you please share these codes in WhatsApp group or your chat window?
Yeah, definitely. So for that thing, yeah, I'll be sharing this with you, but let me go, copy this and then, put it into a proper, format and then do it. So it might, take some time. So we'll be, sharing that with you, through the email. I guess you have shared your email addresses with Dhruti.
Yes, sir.
Yeah. And okay, off the topic, okay, there's one hint or suggestion, that may be valuable for you. There's one WhatsApp group here, wherein we all are members. I mean, along with me, there are other, hardware geeks, who are working actually both in industry, and then some of them are into academics also. So we have a WhatsApp group wherein we make use of hardware. We make reuse of hardware. Suppose if I got a SMPS module or a power supply module, and then I have it lying at the back of at the backyard, and then I'm not using it anymore, I can make it available to you if you are in need. So we are only people from Bangalore, in and around Bangalore. So you can join the team, to either make use of the others hardware, or you can give out your hardware for the use of for the use of others. I'll be sharing that details with you here. I shall send you the link of this group in the chat window. The name of the group is is Doers Club. So can we know from which which year you are all from? I mean, in which like year of study are you from? Starting from Mithun.
Third year, sir. Third year ECE.
From
BGSIT.
uh, is it BGS?
Yes, sir. BGS. PG Nagar.
Oh, yeah, yeah, I got it, got it. Nice. So Dhruti is from third year, right? Am I right, Dhruti?
Yes, Abhishek.
Yeah. Kushal? Okay. So do we have Kushal, or only we have Kushal's phone connected to this? All right, no problem. Saujanya, can you tell which year of study you are from?
Third year.
Third year from which college?
FJCIT. Chikbalapur.
Oh, Chikbalapur. Okay, yeah. Nice. That's nice. Okay. So there's an offer for the second and third year guys. Did someone speak? Okay. Okay, there's an offer for the third and second year guys. That is by the by early May we are introducing internships. Internships on a daily basis. That you should be made to work daily. For 1 hour. So it shall be a around the sector kind of thing. So you shall start from basics of embedded systems, and then you shall go to till the advanced level in embedded systems. And then there's another internship course on OpenCV, and one on MATLAB, and the other specially designed course on robotic process automation. So whatever we learned today is the hardware robotics. So there's something called as robotic process automation. So that's in boom in the industry. So for that, we have one person, who is who has an experience of around 10 to 15 years in automation sector, and also 5 to 6 years of experience working for industry. And he shall be working on automation anywhere. So automation anywhere is a robotic process automation tool. So he shall be the tutor for that particular course. So we have 4 to 5 internships coming up by early May, so that you shall be free by the time you shall complete your VTU exams and all other exams, and then you should be free for joining that. And when it comes to the cost, we are setting the courses at a very minimal or nominal or affordable prices, so that majority can make use of that. And then we have one more opportunity for the students in the academic sector. That is, if you are interested into something, and then if you are good at something, we welcome you, with all warmth. Okay, so you can just join us, and then because we have a set of subject matter experts, so they shall guide you, how to teach, and how to present something, or things like that. So you shall be made a tutor, or an instructor here. And then meanwhile you can earn and learn from from the platform. So you shall be made a professional instructor on the Pile platform. Okay, so any of you can be a teacher. So that's the tagline of our website. So if you open the homepage of the website, it says, we believe every learner can be a potential teacher. Okay, so we just tap the untapped areas within you, and then we just bring out the potential, which you haven't looked into. Okay, so by this, by the end of the session, you can just think, which, if you are good in marketing, marketing does, doesn't mean that, you have to be a salesperson. Marketing means that, how influential, how can you influence people, how can you convince people, right? So that might come towards digital marketing. And you have something called as VLSI, and HTL, VHTL, those subjects, when it comes to your branch of study. If you are good at that, there are too many people who are very bad at that, or who didn't get a chance to learn that. Okay, if you have got that chance to learn, and to learn and excel in that particular domain or in that particular subject, we welcome you. Okay, you can just hop on the board, and you can say that, okay, Abhishek, I shall be a teacher here. So we have got a team. So our team, yeah, as Ruti mentioned in the introduction, we are freshly graduated engineers. And uh, and yeah, at the back we have well trained mentors. Okay, only the execution part shall be handled by us, but we have mentors who work around the clock for their excellence, and for our excellence also. So our mentors are from different parts of the country, and different parts of the world also. So we have our main mentor from the Cincinnati in the United States of America, and then one person from the Australia. So we are here a team of 6 to 7 people here in India, operating out of Bangalore. Okay, so we try to extend it as much as possible. So we are not charging anything for you to be a teacher. Okay, so there's a quote or showing that or saying that, if you can't find a way uh, you know to make money while you sleep, you cannot you know you know you cannot live a happy life. This is something might be slightly modified. It's by Mr. Warren Buffett. So it's our agenda to enable every learner to be a potential teacher. Okay, so whatever you or me invest today for learning, it should not die here. After we pass out, or after we engage into a task in different domain, or different sector, because there are people who are deprived of this what we are getting. Okay, it's a comfort for us, while it's a hard time for them learning this, these things which we have got from our friends, or our colleagues, or from our juniors or seniors. Okay, that's the intention why we are delivering this particular workshop for you, taking out time from our busy schedule, and then taking not enjoying our weekends. I mean, this is for a for a good cause, we believe. So today I had my Saturday and and Sunday in a good way, by just engaging with you guys, and then discussing some good stuff. So this is the way how we, a team of Pi learners, I mean the team at Pylon think. So we we should get out something from everyone, so everyone can teach everyone, every other person, right? So you just after this session, you just sit for some time, just think on it, in which field or which domain you are good at, and then no matter if you're good at at drawing, or at at photography, and then you are into EC, that doesn't matter, because we do not look at your resumes, or any of your previous history. If you have a good track record, that's well and good. If you're a beginner or a newbie, that's more than enough. If you got the enthusiasm to learn, and if you got the interest to work. All right. So with that, I shall finish this, and then and I'm then open to questions. You can shoot your questions directly to me, and it can be related to Pylon, or it can be related to embedded systems, or if in case you have something related to IEEE, you can also shoot those questions at me, because I guess I'm certainly experienced, so that I can deliver your, I can answer the questions related to IEEE also. So we have Dr. Pushpamala here, so she's a senior member at IEEE, and she's very active, and she's a active member at IEEE Bangalore section. So I know her very well, and and the work she has done for the section.
Sir.
Uh, Good afternoon, everyone. I hope everyone liked the webinar from uh, Abhishek. If anyone has any queries, please let us know.
Sir, I'm interested in learning ASCII design verification and floor planning. Is there any available courses or instructors?
No, in specific, we do not have anything related to. I mean, you're asking about ASCII, and and floor planning. That's very specific. So we don't have in anything that specific, in level. But then if you can find out something, if you can find out something, which is good, and then if you feel that particular content is good, you can become a teacher, and then you can learn that, and then you can join the community. Meanwhile, I have noted your response for to this, and then we'll start working on this. Okay. As we told, this is just the ideation was done in 2020, while the while system came online in 2021. We are very new to the in the market.
Yes, sir.
So if you look at the courses which are currently available, in on a website, most of the courses are available on YouTube. Okay. So we have also got the content from YouTube. So what is the reason behind getting content from YouTube and then delivering it for free is, when you or me enter into the YouTube search task, and then say, if I search for you know a course on floor planning, there shall be 1 lakh and odd number of suggestions. In the first page, we get hundreds to thousands of suggestions itself.
Yes,
Okay.
sir.
So I do not know which one is good, or which one is average, or which one is moderate or bad. So I shall look into every video, 4 to 5 videos, and then find out the best of the first page of suggestions. I'm sure that nobody shall go to the second page of Google, or second page of YouTube. Okay. So we shall be wasting that amount of time in searching for the best content. Okay. And then even if you get the best content, if you're looking a course on embedded system, the suggestion next to that player window shall be from a Hollywood, or a Bollywood, or a Sandalwood movie, or a new trailer. That's the biggest distraction to the to the learner. So
Yes.
according to human mentality, so that feels attractive, because that feels that gives us the instant gratification. right? So learning something, it will not give the fruit immediately. So we'll just go up onto the video, or the trailer of Hollywood or Sandalwood film. So that's the biggest distraction. And the third one would be that there would be nobody to certify whatever you learn on YouTube, right? So by keeping all this in mind, a team of people came up with this particular idea. How can we certify people, based on their social media learning, or or something, or like which is available for free? How can we certify that? Okay, so that's how this PyLearn as a team came up, and now it's working as a full-fledged website, delivering content in e-learning market. So whatever courses you see, they are from the online, or from the YouTube right now. Meanwhile, our team is working with people. You can let me know your website to know more information. Sure, Shaisa. It'll be my pleasure. Okay. So there are a team of subject matter experts who shall, who shall search for the best in class content, and then they shall post it on the website. And they should also be framing a set of questions, to certify that he has gone through the basics, and then he knows the fundamentals. So based on that, we shall be giving the certification. So this happens for free. Like, even if you come after 10 years or 15 years, if this platform is active, it will be for free. So that will be a certification for free, e-learning for free. And then meanwhile, our team is working with people, with content creators, dedicated content creators, who are working on on developing content for internships, or for placement preparations, and also for e-learning courses. So this is what is happening currently at Pylon. So we have the placement, preparation drive, that is scheduled for the for the month of May. Say it might go live some time between mid-May, or by the end of May. Okay, let me know the. Okay, I'll just type the URL of the website. You
Yes.
can just go to the link, and yeah. Okay, this is the URL. You can just put it in the browser, because as I told, the company is very new. The search engine optimization is yet to be done. Okay, so if you learn in the if you search in the Google, you might not get the actual pylon.online. You might get some other company, or some other website. And one feature about this pylon is, we shall not add any courses manually. We have developed our own bot using the robotic process automation technology. We shall only tell the bot from where to get and what to get. That's all. So the bot crawls the browser, or the internet media, and then it gets that particular content. It'll just get all the data from that particular video, and then it'll upload into the website by creating the certificate. Everything will be done by the bot. So there's not much of manual tasks that we are doing at the back end. We shall only manage people and things. So that's the reason we are very interested in teaching this robotic process automation to people around. So if you are a student, and then if you have got something repetitive to be done, and then if you feel that you're bored of doing the same things again and again, you can make use of this robotic process automation. One good thing about this robotic process automation is, nowadays it has got AI and ML, along with NLP included in this. You need not start your machine learning algorithm from scratch. You can directly get the libraries, and then put it into the RPA toolbox, and then you can run it. So this is how our website is designed at the back end. In the front end, we shall make sure that everything looks good. So Mithan, so we have a course related to digital VLSI and HDL. You can look into that course.
Yes. Looking now. System on chip and embedded C.
Yes, you are right.
as we are in the as we come to the end of the wonderful workshop, I would like to thank Pi Learning Platform for hosting it and immense gratitude towards our speaker Abhishek for conducting a very interactive hands-off workshop and explaining every single detail. Hope you all gained some valuable knowledge about robotics from this workshop. Um, and thank you,
Kushal,
Pushpamala ma'am, for
Kushal,
hello
sorry for interrupting. It is Pi Learn. It's not
learning.
Pi
Yeah,
Learning.
Pi
It's Pi
Learning.
Learn.
Yes, sir. Can you
Yeah,
come again?
yeah. It's Pi Learn, and at
Yes,
the
yes,
end,
Pi Learning.
after you finish, we have a special gift to all the participants here.
Yes, yes, yes. And I thank Pushpamala ma'am for hosting this wonderful event. Over to you, Dhriti.
Thanks for conducting about embedded systems.
Durdi, we could not hear you. I mean, at least me.
Can you hear right now?
Uh,
I think she
I
has
don't.
a internet problem.
Yes, Durdi, your voice, looks to be feeble.
Dhriti?
Yeah, okay, Dhruti. Thanks for this. I got your message. And yeah, folks, I have shared a coupon code with you. You can make use of this coupon code. This coupon code is worth 250 rupees. If there are any courses on the website which you feel good for you, if they are paid, you can make use of this coupon code, to get the discount of around 250 rupees, anytime till August 2021. Okay. So this would be a special gift only for the participants of this, IEEE Bangalore section, Gurukul, in collaboration with Pylon's workshop, a 2 days workshop. This coupon code can be made use of from tomorrow, not from today, because this is being generated right now. You can use it from tomorrow. Kushal and Dhruti, are we done? And can we wind up? Okay, all. Thank you all for for joining the session. Hope you got something from this, and I would look forward to meet you again, in person sometime later. Okay, I'm looking forward to Pushpamala Madam for coming up with few more events like this. We are all ready to help this to help particular Bangalore section, and also to all the learners across the section. Thank you, Dr. Pushpamala and Dhruti for the whole and Dhruti and Kushal for hosting this.
Thanks, Abhishek.